Okay, what questions do you guys have today? 16 through 19? 16 through 19? Okay. And this is 5-1 or 5-2? The one from Monday? Okay. Okay, so draw our pictures. These right-hand endpoints for each of the evaluation values. Our function was 2x. And we're on the interval 1 to 5. And right-hand endpoints equal subintervals, n of them. Okay. So we're going to split this up into n intervals, and we're going to pick an arbitrary rectangle to deal with. Let's say that this is the kth rectangle. Okay. Where is the kth rectangle? We want to know these 4 points on the rectangle. If I know those 4 points, I'll know everything I need to know about the rectangle. Okay. So if this is the kth rectangle, I have to figure out what these two x values are so I can figure out how wide it is. Well, I'm going to figure out how wide it is first, and then I'm going to figure out where these 2 points are. But I need to know those points because I need to know the y value up here. So I need to know this point for sure. And so our delta x is going to be 5 minus 1 over n, right? Because that's the width of the entire region that we're looking at. We're dividing it into n bits. So delta x is 4 over n. And I've got n of these things. I'm going to go from k equals 1 here to k equals n here. So this k value, this is going to be at, well, if this is the kth interval, there are k minus 1, 4 over n's in front of it. Is that right? So 1 plus 4 over n times k minus 1 will be this value. And this one will be 1 plus 4 over n times k. Does that make sense? So let's look at the very first rectangle. This is the first rectangle, right? But I don't want this. This should hold for any of the rectangles. So if I put 1 in here, I still want 1 to come out because that's where my left-hand endpoint of the very first rectangle is. So if I put 1 in here, I get 0 of the width because I haven't gone any width yet at this point. No, that's not the reason. No. It's because that is the actual values of these points. I'm going to use the right-hand one, but I didn't make it a K over there because that's the one I was going to use. I made it a K over there because that's what it actually is. So there's 4 over in here, 4 over in here. So on the second rectangle, to get to this side of it, you go through the second rectangle. Does that make sense? So I only, to get to the left-hand endpoint, I only go through K minus 1 rectangles. So I've gone through K minus 1 rectangles. Each of them is this wide. I started here to get to the left-hand endpoint. To get to the right-hand endpoint, I've gone through K rectangles. Each of them is this wide, and I started here. Does that make a little more sense? Let's actually put in some values. Let's say I was going to do 7 rectangles, right? So each of them is going to be 4 over 7. The left-hand endpoint of the first rectangle is still going to be 1. This is going to be 11 over 7, right? And so I will have added 4 over 7 one time to get to the right-hand endpoint of the first rectangle. And that is still the left-hand endpoint of the second rectangle. So I still only want to add 4 over 7 one time to get to the left-hand endpoint of the second rectangle. For the third, I'm going to be at 15 over 7. And so if I'm looking at the third rectangle, sorry, that's the fourth rectangle. Nope, because we're starting here. That's not a rectangle. At the third rectangle, I will have gone through 2 rectangles to get to the left-hand side, but I will have gone through 3 of them to get to the right-hand side. And so I need to add delta x. This is the first, second, third. So I need to start at 1, and then I add delta x K minus 1 times to get to the left-hand side of that kth rectangle. Okay. So there's my left-hand endpoint for the kth rectangle. There's my right-hand endpoint for the kth rectangle. That lets me figure out this guy. And this one's going to be exactly the same height as this one. So really, I don't actually need to write that one down. So we're going to write this one down. This is 1 plus 4k over n, comma, 2 plus 2, 8k. That does absolutely not look like a 4. That was a 4. And this one's going to be, oops, got rid of my line. 2 plus 8k over n will be the second coordinate, because my function is f of x equals 2x. Okay, so the kth rectangle has an area. Area of the kth rectangle is going to be 4 over n wide, and it's going to be 2 plus 8k over n tall. And I want to add these up. So total area is going to be the sum from k equals 1 to n, because I'm adding up the first rectangle, the second rectangle, the kth rectangle, the nth rectangle. And we're going to add up these areas, which is 4 over n times 2 plus 8k over n. All good with that? Yeah. I was doing the left-hand side, yeah, I would use this point, and so the height would be different, but I would still be using the K rectangles and how I've got it set up this time, right? You just want to make sure that your picture matches your algebra. Yeah. And I mean, you can do it with left-hand endpoints. You can use the trapezoid rule where you do it with the left-hand endpoints and the right-hand endpoints, and you take the average. In this situation, I don't think I'd use the left-hand endpoint because it doesn't really. I mean, the left-hand endpoint for this rectangle is the right-hand endpoint for this one, but that's just sort of how things work. It's not we're using the left-hand side for some specific reason there. Is that kind of what you were asking? Oh, not really. In most of these pictures, if you draw a representative rectangle and label all the coordinates on that representative rectangle, you're going to kind of have everything you need. And so the nth sum then is going to be this thing. Type that in. Equals 1 to n, 4 over n, 2 plus 8k over n. That's not what it wants, huh? Oh, it wants us to evaluate it. It looks like it wants us to evaluate it. Well, maybe not. They didn't have the what? The index? The sigma? It didn't have the sigma in the answers. Okay. So yeah, it wants us to evaluate this summation and then write down what the algebra is. I thought it just wanted the summation. Like I thought it wanted the expression there. But it wants us to actually do the algebra to simplify this. So we'll do the algebra to simplify it and then go back. Okay. So what can I do with this? Well, I can pull 4n outside. And then I've got a 2, and I've got a plus 8k over n. And I can split that up into two summations, 4 over n, sum of 2 from 1 to n, plus 4 over n, sum 8k over n. Okay. This is just 2n because you're adding up 2n times. So that's actually just multiplication. So you got 4 over n times 2n plus this. We can factor out the 8 over n and get 32 over n squared times the sum of the k's from 1 to n, which those n's cancel. You get 8 plus 32 over n squared times the sum of k from 1 to n is n times n plus 1 over 2. So this is 8 plus 16 times n plus 1 over n squared. Questions on my algebra? Really? Apparently the book has questions on my algebra. Oh, I didn't put an n squared in the denominator. That's why. There we go. And then I didn't simplify the ends. Great. And yeah. Okay. That cancels. You get 8 plus 16 n plus 16 over n, which is 8 plus 16 plus 16 over n, which is 24 over 24 plus 16 over n. We just didn't simplify enough. Sorry. And then we take the limit as n goes to infinity, so you get 24 as n goes to infinity there. Let's try another one now that we kind of know, or now that I kind of know what it's asking for. Okay. Graph. Get a parabola, 1 to 5. This is x squared plus 1. I'm going to draw in a representative rectangle. This is going to be the kth rectangle. And does it tell us the right-hand endpoints? Okay. So we're going to use this guy to draw our rectangle. And then I'll want to know these guys here as well. Okay. So delta x is 5 minus 1 over n again, which is 4 over n. And so we have the same formulas for the x values, the x coordinates. We're going to have the left-hand side. Oh, it's 0 to 5. Okay. That changes things. So it'll be 5 over n. So we won't have quite the same formula. But I will have to go through k minus 1 rectangles to get to the left-hand side. So I will start at 0. And then I will add 5 over n, k minus 1 times. That'll get me to the left-hand side. X value. The right-hand side, x value, is going to be, well, I will start at 0 and go 5 over n k times. And that's probably why it uses the x value. The right-hand side is because you're going to use the k rather than the k plus 1, k minus 1. You don't have to float that k minus 1 around everywhere. Okay, and then so this point, so I've got this point. This point is at 5k over n, comma 0. This one's going to be at 5k over n, comma 25k squared over n squared plus 1. So the area of kth rectangle is going to be 5 over n times 25k squared over n squared plus 1. Questions on drawing the picture, representative rectangle, labeling it, and getting everything that we need? drawing these representative rectangles is extremely helpful, so get good at it, because come Calc 2, you will be seeing these all over the place. Calc 3 as well. They're really useful for trying to understand and figure out what's going on in some application type problems. Okay, so sum k equals 1 to n, because I want to add up all n rectangles. The kth one has an area of 5 over n times 25 k squared over n squared plus 1. So that's going to be sum k equals 1 to n of 125 over n cubed k squared plus the sum k equals 1 to n of 5 over n. So I distributed here, and then split up the sum. Everybody good with that? Okay. So this is 125 over n cubed times the sum of the k squareds is n plus 1, 2n plus 1 over 6. And then this is plus, there are n of those, so it's just going to be a plus of 5. We can simplify a little bit. Cancel out that, make it a 2. So I get 125 over 6. And then I've got n plus 1, 2n plus 1, n squared, and a plus of 5. I don't see anything that I can simplify or cancel more there, so we'll just write that. Okay. Questions on that one? Yeah. How the 5 over n turn into a 5? You have n copies of this that you're adding? Yeah. So n copies of 5 over n is 5. Okay, so as n goes to infinity, what happens? Well, the n plus 1 times the 2n plus 1 squared over n squared, that's a quadratic over a quadratic, so that's going to go to the leading term, so that's going to go to 2. So you're going to get 250 over 6 plus 5. And 250 over 6 plus 5. Let's write this out. This bit goes to 2, right? Because of that leading 2. So this is equal to 250 over 6 plus 5, which is going to be 280 over 6, which is 140 over 3. Where do we have questions on this one? You guys want to do this one too? Okay. I don't know what this quadratic looks like, but I know it curves up positive, so maybe it looks like that. We're going to go from 0 to 1. Well, it certainly can't look like that because at 0 it goes through 0, so maybe let's at least get that part right. At 0 it goes through 0, so it'll look something like this anyway. And we're going to go from 0 to 1. And we're going to break this interval up into n subintervals. So I need a representative rectangle for one of those subintervals. Delta x is 1 over n because the total width here is 1. And so the left-hand side is k minus 1 over n. The right-hand side is k over n. So this point is at k over n comma 0. That makes this point at k over n comma, my function is 5x plus 7x squared. So this is going to be 5k over n plus 7k squared over n squared. That's what that coordinate is. Everybody good with my rectangle? I could label this side too. This is k minus 1 over n if I want to, comma 0. And that would allow me to figure out exactly what that width is, but I already know what the width is because we calculated it, right? It's width is 1 over n. Okay, so the area is, well, it's the height times the width. So 1 over n is the width, and the height is 5k over n plus 7k squared over n squared. So my Riemann sum is going to be the sum from k equals 1 to n. 1 over n, well, let's multiply this out, distribute it, make that easier on ourselves. Got 5k over n squared plus 7k squared over n cubed. Now we'll split this up and factor out the stuff that doesn't involve a k. So I get a 5n squared, sum from k equals 1 to n of k, plus 7 over n cubed, sum k equals 1 to n of k squared. So I'm adding up the rectangles, and I took a representative rectangle. I took the kth rectangle. I know there are going to be n of them, and I've in my head when I drew the representative one, I knew the first one was over here and the kth one is over here. So I have a k equals 1 rectangle, a k equals 2 rectangle, all the way up to a k equals n rectangle. And so that's what this says. This is the area of the kth rectangle. I have a rectangle for k equals 1 till I have n of them. Does that make more sense? Okay. So in this situation, yeah, because you're always going to have a first, second, third up to nth rectangle, you're always going to start at 1 and end at n. But summations don't necessarily always start at 1 and end at n. Yeah. Okay, so we're good with this algebra? Okay. 5 over n squared. The sum of the k's is n plus 1 over 2. The sum of the k squareds is n plus 1, 2n plus 1 over 6. Okay, now I can simplify a little bit. That n and that n cancel, that n and one of those cancels. So I get, this is 5/2 times n plus 1 over n plus 7/6 times n plus 1, 2n plus 1, n squared. And so the limit, or the actual area, is going to be the limit as n goes to infinity of this stuff. Oops. And this goes to 1. This goes to 2 because of that 2. So this is equal to 5/2 plus 7/3, which in terms of sixths is 15 plus 14 over 6 is 29 over 6. So those are our two answers. Plug them in. We already found both answers. So our first answer is that sum, 5/2 of that plus, you got 7 n plus 1, 2n plus 1 over 6n to the second. Okay. And then this one is the 29 over 6. Okay. Where do we have questions on these types of problems? Yeah, the geometry, the picture. Yeah, it takes a little while to practice those pictures. But yeah, being able to draw a good picture in math and science is super important, and it just takes practice. Making sure you know which things are relevant, and I guess the best way to do is just start drawing everything and have a good eraser, because if you draw in too much stuff, you take it away. But draw in as much stuff as you can and label as much stuff as you can, and then kind of pair off the stuff that you maybe don't need. But for most of the calculus stuff, all you have to do is draw one rectangle and label that one rectangle, because that one rectangle, if you've done it right, you have a variable in there that represents which rectangle you're at, and then that representative rectangle can take the place of any of the rectangles that you're drawing. And this representative rectangle, we're finding areas right now. You can use it to find volumes. You can use it to find work. You can use it to find all kinds of stuff with integration in the future. But integration, the best picture for integration, at least in my head, is drawing a representative rectangle. And then with that rectangle, you can do all kinds of stuff. Like, you could think of rotating this picture around the x-axis, and you get kind of like a cone thing that's on its side. And with this representative rectangle, you can find the volume of that cone. You can find the surface area of the cone. You can find all kinds of stuff just from this little picture, depending on what you do integration-wise. But that's kind of an important picture to be able to draw. We probably have time for one, maybe two more questions. You want to try 19 too? We got a cubed in there, finally. Do the cubed one. Oh, and we're on the negative side of the interval too. Okay, so this goes through 0. It's a cubic function. It probably looks like this a little bit. If I put -1 in there, I also get -1, so -1 to 0. I am actually finding the area under this curve here between -1 and 1. That's what this picture is asking me to do. Okay, so let's draw a representative rectangle. Let's just pick one of these. We're probably going to use the right-hand endpoint again. Yep, that makes things easy. So there's our representative rectangle. This is the kth rectangle. Delta x is going to be 1 over n. Okay. So this side, that's going to be at -1 plus 1 over n times k minus 1, because I will have gone through k minus 1 rectangles to get there. This side will be at -1 plus just k over n, because I will have gone through all k rectangles to get to that side. Does that make sense? Blow this up. This point is going to be at -1 plus k over n, comma. Well, I got to put it into the function. So f of x, 14 x squared plus x cubed. I like writing it that way better. I don't know. So 14 times k over n minus 1 squared plus k over n minus 1 cubed. And that's my point on that top right corner of the rectangle. Okay, so that has everything we need to find the area of that representative rectangle. Okay. It is 1 over n wide, and it is 14 times k over n minus 1 squared plus k over n minus 1 cubed. Good. Okay. So our summation, total area of the rectangles, sum over all the rectangles, they start at 1 and end at n. I got a 1 over n. I've got a 14. I've got a k over n minus 1 squared and a k over n minus 1 cubed added together. All good? I think I have the right number of parentheses. Nope, I've got one too many parentheses. Get rid of that guy. Okay. I can factor out the 14 over n. And I can do k over n minus 1 squared. I can add that to 14 over n sum k over n minus 1 cubed. K equals 1 to n. Still good? Okay. I'm going to distribute, or actually FOIL, whatever you want to call it, but I'm going to expand these guys out because that's going to make things easier on me, because I don't know what to do when the k over n is inside with a -1 here. I can't like pull the n outside, which is what we've been doing. It'd be really nice just to have sums of k to some power again, right? Because that's what we've been doing. So somehow I have to turn this into something that looks like k to some power behind the sum and everything else outside the sum. So to do that, I need to get the k's out of the parentheses so that I can sort of factor out everything but the k's. Okay, so we're going to expand this whole thing out. And actually, I'm gonna rewrite it. Sorry, as this, and we'll expand that out, and then we'll combine like terms, and then we'll have 4 different sums, one for each of the powers of k. Okay, so this thing squared is k squared over n squared minus 2 k over n plus 1. This thing cubed is plus k over n cubed, k cubed over n cubed, plus, nope, minus, because that minus sign, I'll have a minus 3 k squared over n squared, plus 3 k over n minus 1. We talked about Pythagorean theorem, or not Pythagorean, the Pascal's triangle and expansion of this stuff earlier this year, right? Okay, so that's all I did here. The third row of Pascal's triangle is 1, 3, 3, 1, and so from that expansion you get this. Okay, now let's combine stuff. Okay. I've got the k, well, let's put the k cubes first. K cubed over n cubed. There's just one of those. I've got a k squared over n squared there, and I've got a k squared over n squared there. There's 1 here, there's 3 there, so that's minus 2 of those altogether. Okay. I got k over n, and I got k over n. There's 3 of them here, there's minus 2 of them there. That's plus 1 over one of those. I've got a plus 1, and I've got a minus 1, so that's plus 0. So are we good with this as the simplification of this? Okay. And now I get to write it as 3 summations with the k cubes, the k squareds, and the k's. So got 14 over n. I will factor out an n cubed, so that's going to be an n to the 4th. And then I will have a sum k equals 1 to n of k cubed. Plus I will have a 14 over n. And I will have a minus 2. So that's going to be actually times minus 2. I'll have n squared, so I'll have n cubes in the denominator, and this will be the sum of the k squareds. And then lastly, I still have the 14 over n, but I bring that n outside, and it's an n squared, and this is going to be k equals 1 to n of just k. So those 3. All right. 14 over n to the 4th times n plus 1 over 2 squared, that's the sum of the cubes, plus I've got minus 28 over n cubed times the sum of the k squareds is n plus 1, 2n plus 1 over 6, plus 14 over n, and then the sum of the k's is n plus 1 over 2. So this is 14 over 4. I've got n squared, n plus 1 squared over n to the 4th. That guy simplifies. This is minus 28 over 6, n plus 1, 2n plus 1 over n cubed. It becomes a squared after that cancels. plus 14 over 2 n plus 1 over n. Those guys. This should be an n squared, right? Yeah, there's the n squared. Didn't have that down there. Okay. And so I'll still have an n down there from the n squared. Otherwise, things would have been wrong. Okay. So I've simplified that. We can take a limit to find the actual area. So this is going to be n squared, n plus 1 squared. Those go to 1 because the leading coefficients are 1. So that's 7. Limit. This goes to 2 because you get the leading coefficient of 2 on the top. So this is going to be 28 over 3. And this goes to 1, so this is also goes to 7 again. So this is going to be 14 minus 28 over 3, which is, well, that's 2/3 of 14. So this is going to be 14 minus 2/3 of 14 is 1/3 of 14. It should be 7/2. Okay, so that screws stuff up. Thanks. Well, it fixes stuff. It doesn't screw it up. It screws up what I had. Okay, let's try this again. I want sixths. So that's 21 over 6. Put it over here. 21 over 6 minus 56 over 6 plus 42 over 6. So that's 63 over 6 minus 56 over 6 is 7 over 6. Okay, so let's try putting that stuff in, and we're out of time. So if you need to go, you can go. I'm just going to finish typing this thing in. So we've got 7 times that's the first piece of the sum. Plus we had negative 14 times n plus 1, 2n plus 1 over 3n to the second. After I simplified 28/6 to 14/3. And then lastly, we have plus 7 n plus 1 over n. And I didn't like that. It is still 7/2. I don't know why I keep doing that. Okay. And then 7/6. Okay. So we got through 4 problems in 50 minutes. That's kind of how these go, because there's a lot of algebra to it, right? There's a lot of geometry and algebra kind of put together into one to actually answer these questions. And the good thing is we find shortcuts in the next section, but it's good to know how to do this, because this technique, this idea, the setup is really good for when you're trying to solve harder problems. You can kind of draw the picture this way, and it gives you a better idea what you need to do on those harder problems. Okay. Have a good weekend.